Hello guys, welcome to the series which is on machine learning fundamentals. We are at a very interesting stage now. We have discussed some of the core machine learning algorithms in the previous series, which was 15. And in that, in fact, we have discussed some of the, some of the machine learning algorithms that are based on proximity. And in fact, they are in the supervised category. Now it is time to come to the unsupervised machine learning. This is not for the first time that we'll be discussing it. We have discussed unsupervised machine learning and its fundamentals. There's a separate episode for that, where we have given the basic concepts of what unsupervised learning is and what are the application areas of this. And then in a separate episode, we have also discussed some of the basic unsupervised learning models. For example, we have discussed k-means, and then we have discussed PCA, principal component analysis, as well, and the related concepts which are there that we have discussed. In fact, the fundamental concept of clustering and all those things we have discussed. Now we have reached to a point that we shall be discussing some of the more advanced machine learning models in this unsupervised category. And let me share my screen with you. And we are going to discuss hierarchical clustering. In fact, first of all, some of the concepts which are there, and then gradually we'll be just, maybe in second part of this particular episode, we'll be, grabbing and discussing about some of the algorithms which are there and their practical implementation using Python. So agglomerative and divisive approaches are there. Hierarchical clustering. This is not for the first time. Probably we are just hearing the name clustering. We have discussed it in quite a detail before. And what is, in fact, first of all, hierarchical clustering? We'll explain this, and then this is an unsupervised learning for nested clustering, in fact. So hierarchical clustering or nested clustering. Hierarchical clustering is an unsupervised learning technique that builds a hierarchy of nested clusters. So it is building the hierarchy of nested clusters. So nested means one cluster inside another, a cluster inside cluster inside cluster. That's a nested cluster. Like you're having, for example, a nested for loop. Because it will be easier for somebody who's in the related field, because basic programming things will be known to you. So nested for loop, for example. So nested clustering is a cluster inside a cluster. So there are two approaches, in fact, in this. One is we are going to discuss that, deep dive into that. But first of all, you need to understand this hierarchical clustering. What are the two approaches with which this hierarchical clusters or nested clusters are, it's building the hierarchy of nested clusters, in fact. So what are the two approaches which are there? First one is called as agglomerative, which is bottom up approach. So each data point starts at its own cluster. So every data point is starting at its own cluster, and then it is iteratively merged. So then clusters are iteratively merged. So they form a nested cluster. Divisive top-down approach, which is one cluster is split recursively, less common. So this particular approach, which is a top-down approach, which is a little less, but it is also used, which is called as a divisive, where a cluster is splitting into, recursively splitting into less common. It's splitting into other clusters. This approach is little less common, but it is also used. Core concepts of hierarchical clustering. What are the core concepts? First of all, a cluster that we have discussed. This is not for the first time, but anyways, we'll be just again throwing some little light on this. A group of similar data points that share common characteristics. We have discussed in quite a detail, I believe. So I don't think it needs more explanation. Linkage criteria also, in fact, was discussed earlier. A method to measure distance between clusters for merging decisions. So this is a method, way how you can merge the clusters, how the decision of merging will be taken. So this will be linkage criterion. And then Dendrogram is in fact tree diagram, visualizing the sequence of clusters merging steps. So we can just see from this. This is a graphical representation of these clusters, wherefrom we can just visualize the sequence of clusters, and the merging steps which are there, how they are merging. So these are the basic fundamental terminology which is going to be used. This linkage method, measuring cluster distance, key linkage criteria, which we have discussed the criteria on which is there. There is a word linkage, minimizes variance, increases when merging clusters, producing compact, well separated groups. It is most commonly used method in practice. So there is a linkage method which is called as word linkage method. So this is a most commonly method used for linkage of clusters. This what it is doing is merging clusters, producing compact well separated groups are there when you are merging them, and then it is the most commonly used method in practice. This is this particular, because we have discussed it earlier as well. When we are talking about linkage and cluster, there is a problem that variance might be, but it minimizes the variance increase which can happen when merging. So that is a problem which can be there, and this is minimizing that. So then you are having, for example, the single linkage formulation. So there is in fact the expression mathematical formula as well for that. We'll be discussing this probably in the second part of this particular episode. So minimum distance approach measures the closest distance between any 2 points in different clusters to determine which cluster should be merged next. So it is taking actually a decision of merging the clusters based on the distance which is there between 2 points. So that's why this is called as a single linkage formulation. One is that we are having word linkage. So word linkages, that means there is not a single point which will be there. There will be multiple points which will be in fact which will be inferring towards the merging, and based on that, that's why variance will be minimizes the variance if you are having a word linkage. But single linkage formulation is a single point. It is saying measures the closest distance between any 2 points in the different clusters to determine which cluster should be. So any two clusters having two data points which are very close to each other will be inferring, or it will be suggesting that these two clusters should be merged. So single linkage is their formulation, and there is in fact a word linkage formulation. So mathematical definition of word linkage, if you just see, word linkage is a mathematical expression which we are going to discuss in fact in detail probably in the next this video of this episode, next part. So variance minimization, how variance minimization happens when we are having a word linkage. Ward's method merges clusters that minimize the total within the cluster. Variance increases. So when we are taking the Ward's method, it merges clusters that minimize the total within cluster variance. So increase producing more compact and well separated clusters. So it will be producing more compact, because we are not having actually a single linkage there. It is multiple linkage which is there. That will be in fact having linkage in multiple points, and that's why word linkage is in fact, it is minimizing the variance, and it is in fact producing the clusters that are much more compact and well separated clusters which are there. So this is in fact we'll be discussing the mathematical expressions of this. So what we have discussed up till now is in fact the hierarchical clustering. First of all, what hierarchical clustering is, and there are two approaches of this, agglomerative and divisive. And one of the approaches, Divisive, is not so common, but this is, one cluster is splitting and recursively. So this approach is little less common, but there is a bottom up approach where each data point starts at its own cluster, and clusters are iteratively merged. And then these are some of the fundamental terminology concepts which are there, which we have discussed earlier as well. And then linkage methods are there. We have seen the word linkage, and there is a single linkage formulation. And in fact, these are having different characteristics. And we have seen that how the variance can be limited when the word, when we are choosing the word linkage. So I shall be stopping at this point. We are normally having it as a trend that first video which is there, it will be little light, it will be some 10 to 12 minutes video, and then we will just, in the same series, because this is just an intro. So intro to this, and we shall be opening up all these concepts which are there. We shall be dissecting them one by one, providing a appropriate program which will be implemented for the concept, will be implemented in Python. You will understand all of these concepts in quite a detail, with mathematical expressions explained in detail as well. So thank you so much once again for joining. You can provide us your valuable feedback so that we can uplift this particular series as well as the channel overall, which is there. And provide us your critical feedback so that we can just make certain changes wherever, whatever, based on whatever suggestions our viewers are providing us. And subscribe the channel in case you are feeling that this is beneficial for you, because there will be a lot of informative things which will be related to machine learning, artificial intelligence, in fact, cyber security, various security series are there which are upcoming. And in the same manner, there are various areas in machine learning, especially the machine learning applications in different areas, which, for example, are not limited, but they are significantly, for example, in the fraud detection, anomaly detection, cyber security, use of machine learning for medical diagnosis, and the related areas, use of machine learning for student performance prediction. So such kind of application areas will be comprehensively explored in this particular channel. So please subscribe to the channel in case you are feeling that this is beneficial for you. Thank you once again for joining, and see you on the other side.